What are the 7 other isomers for 2,2-dimethylpropyl or neopentyl? Here, it's actually not a parent chain, but it's an alkyl group. So our isomers are going to be alkyl groups instead of parent chains. And there are 5 carbons in neopentyl, so we'll start drawing a pentyl. And it's a good idea to check how many carbons you got. There's 5, so that's our first isomer, pentyl, alkyl branch. Then we can go down to butyl, 4 carbons as the main 4 carbons as the main alkyl branch, and then add a bend to account for the parent chain. Be careful, the bend can actually throw you off as to how many carbons you got. It's an illusion, so make sure to double count how many carbons you got. So this is a butyl. Now we're 4 carbons, we need 1 more carbon in. Let's add a methyl. Likewise, we can add the methyl here or here. But you might ask, wait a second, if I'm counting my direction of the carbon of the branch so that the branch has the lowest number, so that must mean this is 2-methyl, but this is also 2-methyl because 1, 2. So that is right in the parent chain, but not right in an alkyl branch. So in an alkyl branch, you start counting from the direction of the parent branch, but you don't start counting from the parent branch. So you start counting from the carbon that's closest to the parent branch, but do not start counting here, okay? So this would give us 3-methyl, and then a butyl group. Here there is 2-methyl butyl group. And lastly, this starts at 1-methyl butyl group. So once again, you start counting this way, starting from the direction of a parent chain, but do not start from the parent chain. Easy mistake. Now we got our butyls, let's go to our pentyls. So pentyls have 3 carbons. That means we need 2 more carbons to get to neopentyl, and those 2 carbons can be expressed in 2 ways. The first is methyl, which we've seen. The second one is ethyl. So we'll start with our propyl group, 1, 2, 3, bend to account for the parent chain. Make sure there's actually 3 carbons, this being the first because it's closer to the parent chain but not on the parent chain. So then we need to add an ethyl. Usually we add it in the middle of the group because if we add it to the end, it actually extends our parent chain. It extends the parent chain of the alkyl group so that it becomes a butyl again instead of a propyl. So our ethyl is going to go on the first carbon. That's going to be 1 ethyl propyl. Yeah. And there's nowhere else that we can put our ethyl because this is going to extend it into a butyl. So we'll go down to our methyls. Once again with our propyl base, 3, and then a bend to account for parent chain. The propyl has 2 methyls. We can put them here and here, or we can put them at the same spot. Okay, so we're going to count starting here, not here. 1, 2, 1, 2. So this is 1, 2 dimethyl propyl. This is 2, 2 dimethyl propyl. And this will start from carbon 1. So 1, 1 dimethyl propyl. So this would be the strategy you use to draw any isomers, even if it's a parent chain. You start from let's say the highest is pentane. So you start from pentane and you go down to butane and then propane. While you go down, you will account how many extra carbons you need to get to your original parent chain. And you would account for that by seeing, oh, instead of just adding methyls, now I can add ethyls and propyls, etc. And so yeah.